Alright guys, welcome to Lopi Mastermind Tutorials. I am Lopi of BCH and today we'll be solving 30 questions on Eksu Physics 102. Let's get right into it. So question 1 says, find the force on a 50 centimeter long wire carrying a current of 10 ampere in a uniform magnetic field of 0.35 Tesla if the wire lies at an angle of 60 degrees to the field. Alright, so this is a typical magnetism question. And how do we solve this question? First, we have to know the formula. The formula is F equals I L B sine theta. Sine theta. All right, that's the formula. I in this case represents the current, L represents the length, all right, of the wire, and then B represents the magnetic field. All right, so all we have to do here is input our given values, but we might have to convert in some places if needed. Now the current, we're told 10 amperes, so we input 10 multiplied by the length of the wire. In the question, the length of the wire is 50 centimeter. Of course, we have to convert that to meter. If you want to convert from centimeter to meter, you divide by 100. All right, you divide by 100, which gives us 0.5 meters, which gives us 0.5 meters. So that's the length after conversion, 0.5 meter. All right, so this is multiplied by 0.5. Now, multiplied by B, the magnetic field. All right, this magnetic field, you can find different names for it, like magnetic flux density, magnetic induction. They still mean the same thing. The unit is Tesla. So in this case, they said the magnitude of that magnetic field here is 0.35 Tesla. 0.35 Tesla. All right, and then you have to include your sine 60, which is the angle provided in the question, sine 60 degree. All right, and then here you can evaluate this using your calculator. You should get approximately 1.5 1.52. All right, and now since we are solving for force, the unit is Newton. All right, so that's question 1 done. Just remember the formula for the magnetic force on a current carrying conductor is F equals to ILB sine theta. All right, that brings us to question 2. Question 2 says an air-filled multiple parallel plate capacitor consists of 200 plates having dimension 16 centimeter by 24 centimeter. If the plates are separated a distance of 0.02 millimeter, calculate the capacitance of the capacitor. All right, so first things first, we know that what we are looking at here is a parallel plate capacitor. We have parallel plate capacitor here. That's what we are looking at. All right, so there's a formula for parallel plate capacitor, and when you have a lot of them, the formula for the capacitance is C equals to n minus 1. So n minus 1 now represents the number of plates, n minus 1, multiplied by epsilon naught, All right, that epsilon naught is what you call permittivity of free space. Multiplied by the area divided by the distance. All right, distance apart, not diameter, now distance. So n in this case is number of plates, which is 200. Epsilon naught is a constant which I would require you guys to know. All right, sometimes they are given in the questions, but if it is not given, you should also know it. It is 8.85 times 10 raised to power minus 12 times 10 raised to power minus 12, and then the unit is farad per meter. That is the unit of permittivity of free space. So let us continue. Now, what do we know? What else do we know from this question? We need the area. We know that area is equal to length times breadth. All right, is equal to, and what are the dimensions given in the question? You have 16 centimeter by 24 centimeter by 24 centimeter by 24 centimeter. But before you can multiply these, let us convert them to SI units. So you have to take it from centimeter to meter. 16 centimeter, if you convert it to meter, you're going to get 0.16, similar to what we did earlier, where we divided by 100. All right, so you have 0.16 meter multiplied by 0.24 meter, 0.24 meter, 0.24 meter. Now, use your calculator, and you are supposed to get 0.0384 as the area. 0.0384. Now, what's our unit of area? That's meter squared. All right, meter squared. Now, what else? We have the distance. The distance from the question was given to be 0.02 millimeter. 0.02 millimeter. But of course, we know we have to convert this to meter again. And how do you convert from millimeter to meter? You just divide by 1000. All right. So conversion from millimeter to meter, now we are going to get 0.00002, 0.00002. All right. And this will be in meter. All right. So everything we need now, we have isolated them, and then n is equal to 200. 200. So this means we can then input our values. So c will be equal to now n minus 1, that's 200 minus 1, that is 199. 199. All right, 199 multiplied by epsilon naught, which he said is 8.85. 8.85 times 10 to the power of negative 12 times 10 to the power of negative 12 multiplied by our area, which we got to be 0.0384, and then divided by the distance now, which we got to be 0.0000 and 02. All right. Now, using your calculator, punch this into your calculator to get your answer. Please make sure you do this step. Even though I'm going to provide the answer, you have to confirm if you can actually use your calculator to get the answer yourself. So approximately, our answer is 3.4 times 10 to the negative 6 farad. All right, the unit of capacitance is farad. But we are done here, but look at this 10 raised to the power 6. Do you remember what we call it? This is also called mu, which is micro. So we could have just said the answer is 3.4 microfarad. All right, so that's another way you can find the final answer there. So these two answers are correct. That brings us to the third question, which says a wire having a resistance of 6 ohms, a wire having a resistance of 6 ohms per meter. All right, so basically you remember that the unit of resistance is ohms, not ohms per meter. All right, but in this particular question, we are using ohms per meter, that is per meter of the wire. It's to be used as a heating element in an appliance that draws a current of 4 ampere from a 220 volt household voltage. How many meters of the wire are needed? All right, so we need how many meters of the wire? The first thing we'll do, let's use Ohm's law. V equals IR. V equals IR. Now, we are looking for the resistance now, so we can make R subject of formula. So if you make R subject of formula, this will give you R equals to V over I. V over I, which is equal to the voltage here is 220, 220. And the current from the question is 4. So we have 220 divided by 4. Now, what is 220 divided by 4? You are supposed to get 55 ohms. 55, 55 ohms. Now, that is 55 ohms. Now, think about this. If one meter of the wire has a resistance of 6 ohms, and we are looking for a total resistance of 55 ohms, that means if 1 meter is 6 ohms, then 2 meters has to be 12 ohms. 3 meters has to be 18 ohms. So we keep multiplying, right, until we get to this 55 ohms. But how do we get the length now instead of just multiplying until we get to that number? We can say the length of wire needed now, the length of wire is equal to the resistance, which is 55 ohms, our measured resistance, the resistance, over the resistance per meter, which is 6 ohms per meter. Now, one thing that can serve as a check on your work is units, all right, unit analysis. Now, if you look at this, ohms is going to cancel ohms from here. And then when the meter comes up, it is just going to be left with meter, and which is a unit of length that we are solving. That means we are doing the right thing. All right, so 55 divided by 6, this gives me 9.2. All right, so our final answer is 9.2 meter. That brings us to the fourth question. The fourth question now says the magnitude of the magnetic force on a charged particle Q or on a charge Q moving in a magnetic field B with a velocity V parallel to the field is given by dash. First, we write out the formula. This is the formula that you need to know, please. Formula for a charged particle moving in a magnetic field B. The formula is Q for the charge of the particle, V for the velocity of the particle, B for the magnetic field now, and then sine theta, which is a factor of the angle. All right, sine theta. Now, from the question, they said parallel. Now, if they are parallel now, that means the angle between them is 0. So this becomes Q V B sine 0. Sine 0. All right, and sine 0 is 0. So you should know where I'm going with this calculation. That means everything here turns to 0. That means the force now is 0. Our correct answer is option B. But this is the formula. All right. Now that brings us to question 5.